Hey y'all, it's me, Miss B, and today we are talking about exponential decay. So we used these equations earlier yesterday. So we've got a equals a sub 0, b to the t minus t naught, or a equals a naught, b to the x. And then we have those listed there. Of course, we use this equation when there's 2 times given, and this one there's only a number of times given. Okay, today we're talking about decay. It was very deceiving. This word before was growth, so go ahead and make that change so that it says decay. That way there's no confusion there. But exponential decay is an equation that is said to model exponential decay when b is between 0 and 1. So let's go ahead and put between 0 and 1, meaning it's a fraction or decimal. Of course, it has to be a fraction or decimal that is between 0 and 1. Okay, so here's an example. I have 1/2 right here. 1/2 is between 0 and 1, and so that is why that is a decay factor there. Okay, so on these problems, let's determine the initial amount and the growth rate. So here, my initial amount is going to be here. I'm going to call that a sub 0 since that's how we usually do it. And then this is my b value. So my a naught is 2, and my b is 2/3. Go ahead and do this next one on your own. What you should have said is that your a sub 0 or your growth rate was, or your starting amount was 5, and that your growth decay rate was 0.1. All right, go ahead and think about this last one. For this last one, we can rewrite as y equals 1 times 0.5 to the x. So our starting amount is 1 and our decay rate is 0.5. All right, let's look at this example here. Scientists in Dayton, Ohio have come up with a cure for the disease that has been turning people into zombies. The antibiotic has been made airborne in order to preserve the safety of the last few survivors. The antibiotic is known to halve the number of zombies in the town each hour. If there are 10,000 zombies in your town, how many zombies will there be 9 hours after the antibiotic has been distributed? Okay, let's highlight that important information in the problem. Go ahead, pause, and highlight. All right, so it says that the antibiotic is known to halve the number of zombies in an hour. There are 10,000 zombies, and it asks how many zombies will there be after 9 hours. Okay, so the beginning of that is really just fluff. Here's what we need. We need a naught, b, and x to go into our a naught, a equals a naught, b to the x equation. Go ahead and fill that out. Our a naught is going to be 10,000. That's the number of zombies we have. B, because it says half, is going to be 1/2, and x is the number of hours after, so 9. So I plug this into my equation. A equals 10,000 times b to the 9. Go ahead and plug that into your calculator and get an answer. What you should get when you plug that in, 10,000. Oh, that's not the right thing. $10,000 times 1/2, or actually, let's go ahead and write that as 1/2 to the 9th. And we get 19.53, which is 20. We don't have 19.5 people. We'll have 20 zombies left at the end. So this is showing the decay of zombies. So what happens is after 9 hours, we only have 20 zombies. All right, and we'll say this last example for class.